Question 14, use the derivative to determine whether the function f of x equals x cubed plus 3x plus 1 has an inverse. Use calculus concepts to explain your answer. Well, we know a function has an inverse if the function is strictly monotonic, and the way that we test for that is to see if f prime is always positive or always negative. So I am going to find f prime on this one. The derivative of that problem would be 3x squared plus 3. And then I am going to find the critical number by setting that equal to 0. And I'll get 3x squared equals negative 3. I'll divide both sides by 3. I'll get x squared equals negative 1. I'll go to square root. You cannot square root a negative number. So there is no critical number. So when I make this chart, there is no number to put on the chart, which means I can pick any number that I want to and plug it into the derivative. I'm just going to pick 0 because that's the easiest, I guess. If I plug 0 into the derivative, I'm going to get a positive value. So this means f prime is always positive. So since f prime is always positive, f is strictly monotonic. So we're going to say yes, the function has an inverse. And I'm just going to say since f prime is always positive, f of x is strictly monotonic, and because of that it will have an inverse. It would pass the horizontal line test. Okay, problem 15, let f of x equal the square root of x minus 4. Find the derivative of the inverse at 2. Okay, first thing that I'm going to do on this one, since I want to find the derivative of the inverse, I'm going to write the formula that you were taught. So f prime of f inverse of 2. Okay, first thing we want to find is the inverse at 2. Remember, if x is 2 on the inverse, it's the y on the original function, so we're going to plug that in for our y value. So we'll get 2 equals the square root of x minus 4. I'm going to solve for x, so I'll square both sides. I'll get 4 equals x minus 4. If I add 4 to both sides, I get x equals 8. So we have just found that the inverse is equal to 8. So now I'm at 1 over f prime of 8. I would like to find the derivative of the function at 8. So I need to find the derivative of the function. I'm going to rewrite the function as x to the 1/2. And since I have parentheses, this will really equal u to the 1/2. So when I take the derivative, bump the 1/2 out front, it'll be u to the negative 1/2 times the derivative of the u, or the derivative of the chocolate. The derivative of x minus 4 is 1. So if I rewrite this, this will be 1 over 2 square root x minus 4. And we would like to find the derivative at 8. So we'll find f prime of 8 will be 1 over 2 square root of 8 minus 4. The square root of 8 minus 4 would be the square root of 4, which would be 2. So 2 times 2 will be 4. So f prime of 8 is equal to 1/4. So now I have 1 divided by 1/4, which is the same thing as 1 times 4. So my derivative of my inverse at 2 equals 4.